Linear and nonlinear functions. How do you know the difference between these type of functions? Well, let's remember some things from Unit 4 on functions and Unit 7 on linearity. First of all, number one, a linear function shows an equation where the input has a one-to-one relationship with the output, and it passes the vertical line test. We have to remember what the vertical line test is. It's when we took a line that was straight up and down, and we ran it across through the graph, and it only touched the graph in one place at a time. If it did this, then it did pass the vertical line test. We assumed it was a function because it had a one-to-one relationship. Okay, going on to number two. A linear function is drawn as a straight line, just like a ruler. So if I was to draw this line like this, it's a straight line just like a ruler, as it was just a moment ago, going up and down this way. All of these directions are showing that yes, it is a straight line. So far it could pass two ways. Remember, it has to qualify in all ways so that we remember about functions. A linear function can be modeled using the rule y equals mx plus b, where m represents the slope of the line. In other words, angle increasing, decreasing, and we know that slope is rise over run, that it's a fraction. And that b represents the y-intercept, and that's where the graph crosses the y-axis. Also, we have to remember in number 4 here, the slope of a linear function is constant. It's the same value no matter what 2 points we choose on the line. Now, so what does this mean? Well, it means if the graph does not meet these criteria, it is not a linear function. It is a non-linear function. So we got to remember what non-linear means. Non-linear means not a line. So if it doesn't meet it, it's not a line. Pretty straightforward. So let's take a look and see if we can graph here a function and determine whether it is linear or non-linear. So we'll put a -1 in place of the x. We're going to keep replacing here. And -1 minus 2 is -3. Let's put a 0 in this time, and 0 minus 2 is -2. We'll put a 1 in. 1 minus 2 is -1. And let's put a 2 in, and 2 minus 2 is 0. Now let's take these, and we know that in a table of values that these are all ordered pairs. Let's take these ordered pairs and put them on the graph. So -1, -3. 0, -2, 1, -1, and 2, 0. If we take that and draw a line through our data that we just came up with, a nice straight line, and make sure that we go through all the points equitably. There we go. And that way we can talk about this for a second. And let's check those 4 criteria and see what's happening. Will this pass the vertical line test? Well, let me get myself a vertical line here and run it through the graph. As I run it through, does it only touch it in one place at a time? It does. So first thing is it does pass the vertical line test. Second criteria, is this a straight line? Yes, it is. Third criteria, is it in the form, can it be put in the form of y equals mx plus b? Sure it is. That's where there's, in this format, there's a y, there's an x, there's a number with the x to the first power, and then there's a constant on the outside. And our last thing is slope constant? So let's talk about slope being constant. Here we see we can go rise over run, and it will be 1, 2, 3, and 1, 2, 3. And that would get us 3 divided by 3, which equals 1. Now let's see if we can check another one out right here. 1 over 1. And isn't 1 divided by 1 also equal 1? So we can prove that slope is a constant. So this meets all the criteria of a function, a linear function. Now let's take a look at this one, y equals x squared minus 2. And the only difference between this example and the previous one is this exponent. This exponent has changed it. Let's see how that's going to affect our graph. Let's put a -1 in, and we'll take a -1 and square it, and then subtract 2. Well, -1 times -1 is +1, and 1 minus 2 is -1. Let's put a 0 in and square it. 0 squared is 0. 0 minus 2 is -2. We'll put a 1 in and square it. 1 times 1 is 1, and 1 minus 2 is -1. Well, we've already gotten the same output with different inputs, so we know that it's probably not a line just based on that information alone. Let's put a 2 in its place. 2 squared minus 2. 2 times 2 is 4. And 4 minus 2 is 2. And let's do it one more time over here with negative 2. We'll take negative 2 and square it, then subtract 2. Negative 2 times negative 2 is positive 4, and 4 minus 2 is 2. So if we take these ordered pairs and put them on our graph, so negative 1, negative 1, 0, negative 2, 1, negative 1, 2, 2, and negative 2, 2. And we can see how this is shaping up, that it's not going to be a straight line. It's going to be a U shape as it continues out and along like this. And what we call this U shape is a parabola. So we would say that this is a non-linear function. So let's take a look at these a little bit more closely. These are the same graphs we just looked at a second ago. And let's compare them side by side and find out what can we say about this? What makes them different and what's happening? Well, we can see that where the x is, something is going on with the x. Here it's to the first power. When it's to the first power, we seem to be getting a line. When it's to the second power, we seem to be getting a parabola. So that kind of tells us what's happening and what's going on. But let's take it a step further. Let's take a look at it from this point of view of slope and how that affects it. So here we have a graph, and we're going to graph y equals 2x plus 2. And we're going to use the graphing it by the form of slope-intercept by taking the slope, which happens to be 2, and the y-intercept, which also happens to be 2. We know slope is rise over run, so we'll set it up that way. So let's graph this. We're going to begin at 2, and our slope is rise 2 and run 1. And then we're going to draw a line through those points. Okay. So here we have a line. It's to the first power and it's a line. Very straightforward. But now let's ask ourselves this question. What happens when the slope is a large number? In other words, what if this wasn't 2x plus 2? What if this was 5x plus 2? Well, if that was the case, that means our slope would be 5 over 1. Let's see what would happen. Again, we would start at 2, and then we would count 5 boxes, 1, 2, 3, 4, 5, and over 1. We'd be way up there. And you notice, let me get a line here going. When I graph this line that we've done some work in blue, so I'll put it in blue as well. What happened is, as that number got larger, we got a steeper slope. So the larger the number, the steeper the line. What happens when the slope is a small number? So let's think about that. Instead of 2, maybe it's going to be 1/2. So what if the slope was 1/2? Okay, instead of that. Well, instead we would still start at the 2, but this time we'd go up 1 and to the right 2. Going up 1 and to the right 2 changes our graph a little bit. And instead of being steep like it was with a large number, this time with a smaller number, it flattens out. Gets a little bit flatter as it approaches 0. So we can see how slope has a change on what is happening. Now, this is in terms of a line, and we've kept everything positive. Let's take a look what happens when we're looking at a parabola. So let's take a look at this, y equals x squared plus 2. And basically this will begin at 2, as is the y-intercept. And it's a standard or the norm, and it'll be 1 of using 1. And I'm going to put this graph up here for you to see. And here we have what y equals x squared plus 2 does. Well, again, what would happen if the slope was a large number? In other words, the number that we put in front of the x squared, which right now is 1. Okay, but what if we put a number in there like 3 or 4? What happens is they're saying that that is 4 times the norm or 3 times the norm. What that will do is it will make our graph climb and be steeper. It will climb that much faster. So we can see how steep, and it just climbs that much faster and quicker. What a difference between the red and the purple. What happens if that number is smaller? Well, let's make that number smaller and see what happens. It's going to become wider. So it does get a little wider and gets flatter and when it gets a small number, when it's a large number, it gets steeper. Very similar to what was going on with our line. Now we were looking only at positive slopes. What about what happens when it's a negative slope? Well, when it's a negative slope, instead of going uphill, it would be going downhill. The same would be true for a parabola. Instead of a positive slope with a negative slope, instead what we would do is we'd flip it over and we would get a parabola that was upside down because of the negative x squared. Now what about other values for the exponent? Well, let's take a look at this and let's do x cubed. If we substituted a 0 in for x, 0 times 0 times 0 is 0. We'll put in 1 in for x, and we know 1 times 1 times 1 is 1. We can do the same thing for a couple other numbers. Putting in negative 1, we will get negative 1. But if we put 2 in, 2 times 2 times 2 is 8, and negative 2 will yield us negative 8. If we put these numbers on our graph and then go to draw it, we'll see that it will start to curve up like half a parabola, but then it'll take off and go in the other direction and yield the other way. This is a standard cubic function. What happens when it's a really small number in the exponent, like an x squared? We have to know that y equals x to the negative half, excuse me when I said squared, but x to the 1/2 power. That this is really talking about the square root of x. Y equals the square root of x. So if we were to put numbers in there that we know and could find pairs for, we would put 0 in and find out that it's 0 because the square root of 0 is 0. We can put 1 in there and find out the square root of 1 is 1. And let's use the number 4 because the square root of 4 is 2. That's an easier perfect square root. So we have those numbers. And you'll notice that I didn't offer up any negative numbers. Well, here's why. Can you take the square root of negative 4? You can't, so we're going to ignore that and know that we can't go past the 0. This is as far as we can go. And so we're going to take a curve and it's going to go off in this direction exponentially. And again, this is not a linear function. So let's put together what we've learned from today. When we're looking at the structure of y equals mx plus b, we can take a look at what's happening in terms of the x when it's to the first power. When it's to the first power, we know that it's a line. When it's to an x squared, we know that we're going to get a parabola. We know that when we look at these letters, m represents the slope. And when the slope is a large number, it's going to become steeper, narrower. When it's going to become a small number, the line gets flatter, or the parabola gets wider. The y-intercept is where those graphs, whether a line or parabola, is going to cross the y-axis. So hopefully you understand a little more about linear functions and nonlinear functions and how they relate to each other.